Cool. Hello, everyone. Thank you so much for having us in today for Lido's community call. Let me introduce myself. My name is Jorge Arce. I am a blockchain researcher at Nethermind. And on behalf of the entire Nethermind research team, I would like to present to the Lido community an overview of the results of our latest research project for Lido. So this one is titled White Labeling Resistance, Systemization of Knowledge, Research, and Mechanism Design. Just to give you guys some context, this collaboration is actually part of a multi-phase research project, which has the goal of designing a mechanism for decentralized maintenance of Lido's operator set. And phase one took place last year. It was a systemization of knowledge on the fields of decentralized identity and verifiable credentials. This was completed in late 2022. And now phase two, which will concern us for today's talk, is about white labeling resistance and was completed just last month. So this one is fresh out of the oven. This research, like all of its phases, phase 1, 2, and beyond, are steps towards enabling Lido to onboard new operators in a permissionless manner. So this will integrate with the efforts on community staking and so on and so forth. Here's a screenshot of our phase 1 deliverable, along with the QR code in order for people to consult that quickly. And here's another QR code for people to access our phase 2 deliverable. Okay, before we explain our research and the results, let's have a quick review on why do we focus on white labeling and what does it mean in the first place and why is it important? Well, with white labeling, we are going to understand what happens when operators in a liquid staking protocol delegate their nodes to a third party without the protocol's knowledge. So they are not running the infrastructure themselves. They're just sort of acting as a middleman and perhaps collecting the fees from that. Now, the reason why this is a problem is it can lead to a disproportionate control over the protocol stake by a single entity, which would be the white label operator, the party who is delegated the nodes. In turn, that can weaken the resistance of the liquid staking protocol to correlated slashing. It can introduce single points of failure, so on and so forth. And we note that it is easier to deal with white labeling in the current version of the Lido protocol, where we have a set of vetted vetted operators. However, once we sort of allow permissionless operators to join, that this will, without this vetting phase of sorts, then this needs to be addressed in a different way. Here we note how operators running their own nodes, that is no white labeling happening, is important to the Lido protocol. This is actually the first feature that shows up in Lido's decentralization scorecard, of which I have put the link to down here. And this is something that is currently working very well in the permissioned setting, and we're looking to keep it that way as we move to a permissionless approach. So how would we go about doing that? This is where our phase 2 research comes in. And from discussions with Lido contributors, we had an initial prompt to do research on the design of a decentralized dispute resolution mechanism for Lido, which would be created to penalize misbehaving operators. Now, this dispute resolution mechanism would focus on white labeling for this phase. However, note that it could also be used as a more general tool that would address different kinds of misbehavior. So future research phases in particular could look at stuff like civil attacks, which could also lead to a similar consequence of a single entity controlling much more stake than they are supposed to. So we will revisit this, or we will clarify this idea of how exactly a dispute resolution mechanism works and can be useful. In the meantime, let us have a look at what building blocks would be necessary to build this mechanism. Well, the approach for phase 2 mainly, or the highlights, I would say, of the research could be summarized thus. We first provided a systematization of knowledge on arbiter protocols, this is an umbrella term that we're using to refer to a variety of protocols that could be used to look at a set of evidence, a dispute, and assign a ruling to it. Here we looked at prediction markets, decentralized oracles, and decentralized justice protocols. Once we are armed with the right arbiter protocol to use, we moved on to a mechanism design, in which we looked at the architecture, the analysis of economic incentives, and all the little details in order to make the mechanism function correctly. And in particular, we want to have a very close look at what are the economic incentives for the parties that are involved in the protocol to behave as we would expect them to behave. That is, to behave honestly if they are rational actors. These parties would be the node operators, the accusers, which sort of like keep them in line and look at any cases of misbehavior, and also the jurors who participate in running the arbiter protocol. We will look at these parties in more detail in a bit. And finally, the third highlight would be we also analyzed what sort of evidence types could you produce in order to identify cases of white labeling. And yeah, we will detail them in the next few slides. So this is just a bird's eye view of what we're going to discuss next. We will go into details next. If you look at the deliverable, it has 5 tasks. The ones I have highlighted before are tasks 2, 3, and 4, SOK on arbiter protocols, dispute resolution mechanism proposal, and using heuristics to identify white labels. Tasks 1 and 5 are important on their own right, but in the interest of time, we will be focusing on 2 through 4. So let's talk about the results of the research. Okay, so for our task 2, SOK on arbiter protocols, what we did was we analyzed 35 papers and implementations of arbiter protocols. And we sort of like aggregated all of this knowledge and provided our recommendations as to what would be a good arbiter protocol to choose to build this mechanism. Starting with prediction markets, well, just as a quick review, these are protocols that people can use to bet on binary outcomes of future events. The idea here was to check whether it would be feasible to use a prediction market to bet on a node operator being guilty or innocent of misbehavior, and whether this is a way to sort of like make the truth about the interpretation of a set of evidence surface in a decentralized manner. The reason why this in principle sounds like a good idea is because it can be shown that the prices of binary options in prediction markets can be interpreted as the mean belief of traders. So they are very efficient tools to aggregate this mean belief. So it sounds like we are onto something there. However, and unfortunately, it turns out that the resolution of the prediction market, that is sort of like closing the market and determining who was in the right and who was in the wrong at the end of the day, this is tricky to do in a decentralized manner. Many prediction markets simply run with a trusted entity that does this. And in the case that this is decentralized, one has to be very careful with not introducing conflicts of interest and so on and so forth. At the end of the day, like many prediction markets still rely on another kind of resolution mechanism, such as an oracle of sorts or so. Moving on to decentralized oracles, these are just any mechanism for bringing off-chain data on-chain. And they use different types of economic incentives to incentivize truthful reporting, even when you are dealing with a decentralized set of nodes or parties who are in charge of doing the reporting. So once again, it sounds like we're onto something here. This is a lead we want to pursue. However, most decentralized oracles that we were able to look at, stuff like Chainlink, Yuma, Nest, so on and so forth, they are not the most suited to deal with subjective interpretations of data. And they tend to really shine when you're looking at sort of like providing information about a price feed or an objective parameter that you can measure in the real world and put it in on-chain. So we sort of want what decentralized oracles do of having these economic incentives for people to report what they really think about a given situation, but also be more adequate for providing a subjective interpretation of that data. And this is where where decentralized justice protocols come in. As a definition, we can say these are protocols that use blockchain technology to decentralize dispute resolution by crowdsourcing the adjudication of disputes to a worldwide pool of willing juror arbitrators. But to make that simpler, you can think of them as generalized oracles in which you are able to analyze more subjective questions than simply data relaying and so on. They leverage jurors who are financially incentivized to rule truthfully on questions, usually via shelling point mechanisms, where shelling point is a mechanism in which the majority vote is rewarded and the minority vote is not rewarded or penalized. And the idea is that if there is no coordination between the parties when you set up a mechanism like this one, then the truth will emerge as a natural equilibrium. So yeah, the decentralized justice protocols were the ones that came out on top for our task. We provided a comparative review of existing decentralized justice protocols. We identified the Kleros protocol as the most mature, and this protocol gave us a lot of inspiration as to how to think about dispute resolution in general. And we also analyzed critiques of decentralized justice protocols from blockchain and law experts, and there's a very rich discussion in the deliverable for people who are interested. Now, moving on to the meat and potatoes of the mechanism, where we propose how it works, we propose its design, and we look at the financial incentives, and we look at the sort of like expected values of behaving one way or another, and we check that everything makes sense and checks out so that, once again, rational actors behave the way we want them to behave. Well, this mechanism is going to involve the three parties we were talking about before. You're going to have the Lido operators, which will be posted a bond, which we denote B of N. The bond will scale with the number of validators controlled by this operator. And this bond is subject to being lost if found guilty of any kind of misbehavior, in particular, in this case, white labeling. Then we have the accusers, which are any external party who can submit a case along with the appropriate evidence to the mechanism. They will also be posting a bond because we don't want frivolous cases in the mechanism. However, they stand to gain a reward from if their case is successful. So they should only be submitting cases that they truly believe in. And finally, we have the jurors, which are appointed by the mechanism to arbitrate disputes. They should be knowledgeable enough in several aspects about the Ethereum technology and validators. And they will be splitting a reward, C, the court fees, that will be taken from the loose inside in the dispute between operators and accusers. The mechanism, once again, uses a decentralized justice protocol. This could be Kleros, because of how quickly the landscape of decentralized justice is evolving, or how it's still in its early stages in a variety of places. A different solution could appear in the future that becomes more appealing for the DAO for any reason, or even a fork that is created by the DAO. So we have made sure that our mechanism is modular enough so that this decentralized justice protocol can be swapped out easily if that's needed. So here's an example of how an architecture would look using Kleros 2.0 as the decentralized justice protocol. We have the evidence providers, which we could also call as the accusers on the top left. They obtain insights from Lido validator set. They provide evidence or red flags to, in this case, a Kleros court. We are highlighting Kleros 2.0 here because it has the very nice feature that in its roadmap that will allow us to curate jurors via something that is known as a dispute kit down here. And so it will allow us to draw jurors from a juror set of experts. And then the Lido contract will implement all the logic related to bonds and rewards and what are the right quantities that should be parties should put to stake when they participate in the mechanism, and the punishments for misbehaving. So as part of the research, we provided, because the way the mechanism works and how it needs to be adjusted is dependent on some market conditions, but also on how effective accusers can be at detecting white labeling instances, which will probably require some experimentation. And we have proposed a testnet phase in which we look at these things live. We have provided a simulation tool that recomputes the correct bonds and rewards that are required for the mechanism to incentivize appropriate behaviors or honest behaviors. For a typical example of what we would consider reasonable market conditions, this is a screenshot of a simulation's results. And we notice that the rewards that are paid to accusers, and hence also the penalties that are applied to node operators for white labeling, must be large enough to financially incentivize good behavior. However, under these parameters, we notice that the mechanism does exhibit adequate capital efficiency, which was very nice to notice. Like, for example, here, the minimum accuser's reward that must be given to an accuser that is able to make a successful case against a white label or an operator using white label with 100 validators is in the order of like 5 ETH. So that's comparatively speaking, that's a reasonably small bond, especially when we think about the fact that bonds that cover things like slashing events or MEV stealing must be significantly larger than that. The DAO contributors have been looking at stuff in the order of 1 to 4 ETH per validator, for example. And so this is a couple of order of magnitudes below that. So we take that as a good sign as to the feasibility of what this mechanism is doing. The deliverable goes into a lot more detail. There's just dotting the I's and crossing the T's on all these tiny pieces that must match. Economic analysis of bonding requirements and incentives. The simulation tool is provided. Guidelines for a testnet phase. Description of a fail-safe mechanism for the DAO to sort of like regain sovereignty over the dispute resolution mechanism if it were to run amok in whatever way. And also strategies for jury curation. Finally, for task 4, using heuristics to identify white labels, we provided a review of the literature and known ecosystem insights on how one would go about detect white labeling by means of doing validator profiling and correlation analysis. So this has been known for quite a while that this can be done in Ethereum since at least 2020, according to the sources we looked at. But it hasn't really been taken, in our opinion, and from what we saw from the research, it hasn't really been analyzed to its full potential, perhaps because there haven't been the incentives to do so. But some examples of the things that you could do are, say, training machine learning classifiers and validators' performance in order to identify the fingerprints of different validators and see if they are consistent with being operated by the same entity. This is very similar to the approach that Rated Labs followed for another research that was delivered to the Lido DAO. And on the other hand, we also have networking layer analysis that could correlate validators as being ran by the same beacon node, which could be used as a really interesting kind of evidence that in fact a validator was delegated to a white label operator and is not being run by the entity that claims to be running it. This is just a starting point of what can be done, but we have identified the sources on what is known about these techniques. We do think that if there are with the testnet and financial incentives for accusers to look at these kinds of things and sort of like audit the behavior of validators, this should unearth even more options and like sort of like drive the state of the art forward as to how you could identify white label operators. Some future research directions, I'm almost out of time, but we're looking to improve our dispute resolution mechanism and our mechanism for decentralized curation of the Lido's validator and operator set with complementary or phases related to civil resistance that support or augment what has been found about white labeling. So like an economic analysis of a civil attack for our dispute resolution mechanism. And also reputation systems that can be used for all the parties that are working at work here, operators, jurors, and so on. So this would be next stages for this collaboration that we'll be really looking forward into diving into. And I just want to wrap it up with my sincere gratitude to the Lido community for supporting our research on behalf of the entirety of the Nethermind research team. We look forward to continuing our work together. Any interesting problems that the Lido DAO encounters, it has been a pleasure for us, and we'll be looking forward to doing this more.